11. We are discussing our first lesson, relations and functions, and we have already completed 10 questions of exercise 1.4. So today we start from 11 question. You can open your textbook, page number 25, and check your 11th question. Your set is mentioned on n cross n. Set is mentioned on natural numbers. What is the binary operation is given? That a comma b and c comma d is related in such a way that a plus c and b plus d. Now what is your question? That you have to check that is it commutative, associative, and lastly you have to find the identity element. So let's start with commutative. What is our commutative rule? Let's revise it one more time. That commutative rule is, suppose you are getting A related to B, then the relation of B and A is same. Either you can say this way or you can say A related to B and B related to A. If both are same, then you can say it is a commutative. Okay, so let's continue with this concept for commutative. What is the commutative? That A comma B related to C comma D equal to, we can write A plus C and B plus D. Now the same thing you have to check with C, D and AB. What is the concept of commutative? We have to exchange our element first, second. Okay, so if we follow this, what is the condition applied? A and C, then B and D. So here also we have to take C and A. So first relation is C plus A. Second relation D with B. So D plus B. Now you can check. A plus C, C plus A. Meaning is same. B plus D, D plus B. Meaning is same. So from this you can say that the given relation satisfied the commutative rule. Now the second one you have to check associative. So let's check for associative. Commutative clear. Now we will follow the associative rule. For associative rule we require 3 terms. Which are the 3 terms? Let's check it one more time. This is your associative rule. Right? So same thing we have to follow with A, B, C, D, and one more we introduce on place of C, E, F. So let's start with A comma B related to B, C comma D and E comma F. Right? So what to do? First we are combining these two. So what is the combination of it? That first with first and second with second. That is our condition. So let's keep A comma B as it is, and now you apply C and E together. So we can write C plus E. Second thing D and F. So D plus F. Okay, now again we have to follow the same rule because we are getting 2 elements and here also we have 2. So let's apply first with first. So what you can write? A plus C plus E, and second with second. So B plus D plus F. What do you get? A plus C plus E and B plus D plus F. So same thing let's follow, that A comma B and we are taking C and D together. Now these two in combination and last with EF. Okay, if we apply these two together, then what is our result? A plus C, B plus D. So let's follow this, A plus C, comma, B plus D. Okay, what is the new thing? We have E and F. So let's apply with E and F. Now the concept is same, but our term is changed, that A plus C with E and B plus D with F. So what you can write? A plus C plus E and the second term B plus D plus F. Okay, let's check it. First here also A plus C plus E. Here also we have A plus C plus E. Here we have B, D, F. Here also B, D, F. So from these 2 results, you can say it is associative also. First we have derived that it is commutative also. Secondly we have derived it is associative also. Now the last thing, which one you have to derive, that is identity element exist or not, and if exist, then what is the identity element? So let's find it. What is the condition for finding identity element? If we combine any term with or any relation with E, and if you get A or E with A, if these two answers are same and if it is A, then you can say E is the identity element. Okay, this is the concept of identity element. Now we have to follow over here. So here we have these two elements. So let's assume, suppose A comma B related to C comma D. Its relation is A plus C, B plus D. Now we are taking A comma B with E1 and E2. Just we have pair given, so we have chosen identity in the same way. So it's equal to A plus E1 and B plus E2, because our condition is first with first and second with second. So let's compare first and second with second. But what is the condition for identity element? It's equal to A. A means what? Our AB. So here we can take it's equal to AB. Okay, now what is our condition? That first with compare with first, second compare with second. So what you can compare? A plus E equal to A, and secondly B plus E. I have written E1, E2, so for our convenience we write that only. From both sides A1, B1, A and A cancel, B and B cancel. What you get? E1 is 0 and secondly E2 also 0. So what is your identity element? 0, 0. So this way we have derived that it is commutative also, associative also, and lastly we have find what is your identity element. So these 3 points we have to check in your example 11. Now let's come to the 12th question. What is your 12th question? Read in your textbook. 12th question is short question. You have to check. 2 questions are given. Is it right or wrong? Read first. For a binary operation on n, A asterisk A equal to A. Our first is this. Okay, when we have started binary operation, what you learn? That binary, bi means 2. So here we have mentioned this relation on the same term. If it is with A and B, then only you can say it is binary. Binary means 2 elements, bi. Bi means 2. So we have given with AA. So this is not true. Now the second thing, second one is given that this is your first one which is wrong. And second question is given that this relation is commutative on n. And what is the relation is given? That A related with B and C, similarly C related with B and A. So you have to check is it right or wrong. First of all check that this is commutative. What is the meaning of commutative? A with B and B with A. Meaning remain same for both. So we will follow the same concept here, that we are taking this as a one term. So what we can change? B asterisk C asterisk A we can write if it is commutative. Simply I have exchanged these 2 terms. Now I have to exchange this 2 also because it is commutative. So we can exchange this 2 also. So what is it? It is same as this one. So this second statement is correct. First one is wrong, second is right. This is your 12th question. Now 13th. In 13th question, what is the 13th question is mentioned that the binary operation is given on n. N means a set of natural numbers and relation is given A cube plus B cube. Now you have to check 4 options are given. Which are they? First is associative and commutative. Second is commutative but not associative. Associative but not commutative. And last neither associative nor commutative. Okay, let's check first what is it. First to check commutative. Just we are taking A asterisk B equal to 2 asterisk 3. Now on place of A I have taken 2, on place of B I have taken 3. So what is the condition applied here? That is 2 cube plus 3 cube. Okay, what is your 2 cube? 2 2s are 4 2s are 8, and 3 cube means 3 3s are 9 3s are 27. Okay, what is the total of it? 35. Now the same thing we will follow for B and A. So 3 and 2. What is the meaning of it? 3 cube plus 2 cube. 3 cube means what? 3 3s are 9 3s are 27, and again 8. 8 plus 27 is 35. So your A asterisk B, B asterisk A, both answers are same. What is the meaning of it? It is commutative. Okay, commutative is checked. Now we have to check second thing, associative. So let's check for associative. It is commutative, first part we have proved. Now let's check for associative. That is A related with BC equal to A related with B and with C. Okay, let's check both the sides. 2, 3 and 1. So what is the relation of it? 3 cube plus 1 cube. Condition is same, A cube plus B cube, you have to follow the same thing. Now 2 asterisk into 3 3s are 9 3s are 27 plus 1. So 2 cube plus 28 cube. Now what is this side's terms? 2 and 3 with 1. Okay, 2 cube plus 3 cube plus now 8 plus 27 and 1. Now 8 and 27, 35 and 1. Now when you apply this, 35 cube plus 1 cube. So when you check this, if you get the two answers same, then it is associative. But when you check this calculation, these two answers will not same. So it is not a associative. So this is the last question of your exercise. Now we will start our miscellaneous questions. Now remember, exercise 1.4 is over. So you all have to complete your exercise 1.4 in your notebook. Now we will start, before we start miscellaneous questions, now let's revise what we learned from the beginning. Because in miscellaneous questions, our questions will start with first part. What is our first part we learned? That is the relations. And what is the relation? Reflexive, symmetric and transitive. For your convenience, fastly I revise it once. What is the reflexive relation? Reflexive relation means the relation of a person with himself. So if I consider A with A, relation of A with A, that is called reflection. In symmetric, which example we have taken? If we make a axis against our body, then we get two parts same, two symmetric parts. So what is the condition of symmetric? If A is related with B and the result with B related to E, if both are same, you can say it is a symmetric. Now in transitive, which example we have taken? That if we move one step from this step to here, from A place to B, now from B place to we reach C. So relation of A with B, relation of B with C, then you can relate A with C also. So this is your transitivity. Transitivity means the relation of a two persons, different persons, again two different persons, and then we have taken with first and last. So this relation we can mention A and B's relation, similar way B and C relation, then you will get A and C relation. So just in short I explain you these three. And now one more thing you have to remember, and what's it? If all three properties are satisfied, then this relation is called equivalence relation. So just we have revised our first part, your first 4 questions which are based on this only. So that's why we have revised it once. Now let's start our solve sum miscellaneous example number 41. Okay, read in your book. It is on page number 26. Your question is first 41. R1 and R2 is the equivalence relation. Then you have to show R1 intersection R2 is also equivalence. Now remember, R1 and R2 both are equivalence means what? R1 follow all three properties, reflexive, symmetric, transitive. R2 also follow all three, reflexive, symmetric, transitive. And you have to use these two results and you have to show that R1 intersection R2 also reflexive, symmetric and transitive. Okay, let's start with, suppose R1 is reflexive, R2 also reflexive, right? Then if both are reflexive, then its intersection R1 R2 also reflexive. That is the easiest thing which one we can follow. The same way, R1 is symmetric, then R2 also symmetric. Then if R1 R2 symmetric, then R1 intersection R2 also symmetric. But we have to go on one more another track. That what is it? If R1 intersection R2 is symmetric, then R2 intersection R1 also symmetric. That is the thing of symmetric, or you can say both if are same, then only you can say it is symmetric. Okay, if we take example, suppose intersection of A and B. So if we write A intersection B, we can write the same answer for B intersection A also, because in set theory in 11th standard you already learned this property that union also commutative, intersection also commutative. So we can apply directly here. Now I explain you third thing. Third means transitivity. If R1 intersection R2 means relation of R1 and R2, R2 intersection R3, then you can find R1 intersection R3 also. So this third thing shows it is transitive also. So if all three properties, reflexive, symmetric and third one is transitivity, if we follow all three, then you can say it is equivalence relation. It is already solved in your book. So what to do? You have to follow the method, how writing procedure as the same as textbook. Okay, we discuss the next question. Okay, check your 42 question. 42 is, let R be the relation on a set A, order pair of a positive integers defined by. Now check what is the relation is mentioned in 42, that relation of xy with uv. If and only if xv equal to, what is the relation given? Yu. And again you have to show it is equivalence. Equivalence means what? First you have to find for reflexive, secondly symmetric, and third is transitivity. Okay, reflexive means what? Relation with itself. So if I take this relation, then how can I write? Relation of xy with xy itself. Because what is the condition applied here? You check it. X with v means first and last, and second and third. So here you apply first and last, xy equal to yx, and you know definitely it is true, because multiplication also commutative. We know if we multiply 2 into 3, then we get 6. Same way if you multiply 3 into 2, we get 6. So what is the meaning of it? xy and yx both should be same. Okay, this is our first part. Now for symmetric, what to do? For the second one, relation of xy with uv. So we are having this one. Now I write uv related with xy, because I have to just shift the terms. For symmetric we are shifting terms. First with last, so u into y equal to second and third. So v into x. Check it. Both is same. uy, xv. So we get the symmetric also. And our last, transitivity. Okay, we have taken xy with uv. Then we get this relation. Now I am taking uv with pq. I have taken pq. You can choose any numbers, that is your wish. Now here we apply first with last, U with Q and second with third means P with V. Okay, we have one this result, another this results. Now you have to arrange these two results in such a way that you get what is the result you want? XY related with PQ. First and second, second and third. So now we want first and last relation. So XQ equal to YP. Okay, so how we get this? We want XP and YQ. So we don't want this V and U and V. So simple, you put up the value of U and V over here and you arrange in this format. So what you get? That way we get transitivity. So I think we stop here and we discuss our next miscellaneous question in next class. Thank you.